Alright, welcome back to Little Astrophysicist. In this episode, we are studying for my daughter's second chemistry test in grade 9. It's the second half of chemistry. We're going to be going over atoms, ions, and Bohr-Rutherford diagrams. Let's start with counting atoms inside of molecules. So let's look at this first one. Okay. You don't know this yet, this will be grade 10, but that's sodium carbonate. It's got 3 types of atoms. What are they?
Sodium, 3 types of atoms. Sodium.
Sodium.
Oxygen.
Oxygen. What's the
calcium?
C? No, calcium C.
Wait, hold on. Carbon?
Carbon. Okay. Now, this little 2 tells you what? Do you know?
2 sodiums?
Yes. How many carbons would there be?
0.
0. If there was 0, why would I write it?
3.
Nope.
2?
No.
1.
1. Right? So if there's nothing, I wouldn't write it, right? Because you don't see me writing like lithium and every other single element there, right? That does not exist in that compound. So it's obviously there. But if we don't write a number, that number is 1. So there's 1 carbon. How many oxygen?
3.
3. So in total, how many atoms?
6.
There we go. Okay.
Let me do this one.
All right. What are your 3 types?
Calcium.
Yep.
Calcium. Potassium.
Nope. Potassium is K.
I don't know that. Okay, hold on. I'm trying to remember here. Where's your periodic table?
No,
Do
you
you know
can
God?
remember this.
What?
It's on the end of matchsticks.
What the flip are matchstick? Phosphorus?
Yes.
So phosphorus and oxygen.
Yes. Okay,
So-
how many calcium?
3.
How many phosphorus?
2, 4.
Oh, wow, we were jumping around there.
2.
Hold on, let me
2,
show
4.
you.
4, 2.
So in this case, remember there's nothing written there, so it's like if there's a 1. But then this 2, just like when in math, when it's outside of the brackets, we multiply into everything in the bracket.
Oh, I got it. Okay.
So how many phosphorus?
2.
And how many oxygen?
8.
There we go. So total?
13.
Good.
Let me do this one. Okay, now that's potassium.
Yep.
Potassium has 2.
Cr is chromium.
How am I supposed to know that?
Well, that's why I told you.
Oxygen is 4.
Good.
7.
There we go.
And let me do, what is that? Is that
Okay,
just
so
the...
that is a coefficient. So here we have barium chloride. So inside of barium chloride, we have barium, which is connected to 2 chlorine. So this is 1 molecule of barium chloride. This is saying we have 3 of them. So we have another molecule of barium chloride.
So just times that by 3?
Exactly. So that coefficient, you're going to multiply into every atom by 3.
So, Ba is 3.
Yep.
And that is 6.
Yeah. There we go.
And 9. Oh, wow, that's a really good 9 I wrote.
Okay, good job. All right, next. Bohr-Rutherford diagram.
I got this. Anyway.
Oh, you know these. All right.
I
let's
know
start.
these. Okay.
Lithium, how many protons?
Wait, what's that again?
That's your atomic number.
Atomic
And
number?
the one below, the bigger one, is your atomic mass or your mass number.
Okay, so 3, 3, 4.
How did you get 4?
U minus.
Good. All right, so let's draw.
Okay, wait.
What goes in the nucleus?
The nucleus, so...
Good. And you've got 2 electrons in your first orbit and 1 in your second. 2 in your
whoops.
second. That's interesting.
Whoops. I was thinking of 4, and then you suddenly said, what a god.
It's like,
I was
oops.
like, whoops.
You want to try redeem yourself there with this one?
I redeem what? What? So mass is 40?
40.
Oh, wow, that's a really nice 4 right there. Are you proud of are you proud of me?
Extremely. I've never seen a better 4.
Thanks. Wait, hold on. So I want to say 22.
Yep.
Okay. Do I have to actually draw this?
Yeah.
The circles?
Do your own circles.
Wait, hold on.
Okay, well, they could have been better.
Stop. Wait.
This is a very simple program, so there's no circle. You have to do it yourself. You can just do one circle, not like an art circle where you're just going over and over and over and over again.
It creates like somewhat a perfect circle though.
Mm.
Trust. I'm not used to this pen. Hold on.
we have our artist here.
Swear to
drawing
God,
a Bohr-Rutherford diagram.
Let me try that. Let me just like totally go for
No,
it.
we need
okay?
like a no erasing policy. This is taking too long.
wait, we could like speed run this like. Shucks.
Oh, we're starting over. I can promise you your science teacher's not going to mark how perfect your circle is.
Hold on.
Oh my goodness.
Let me.
Okay, no more erasing.
Okay. Ooh, that was nice. 18, 22, and then you need 2 circles, right? No.
How many can you put in your first one?
Oh wait, 3 circles. My bad.
Oh, we're just gonna do
I
all
got
the
this.
circles first. All right.
Yeah, there we go. No, stop. Wait.
That's fine. That's fine. Okay, so your first orbit, you can fit 2.
2,
And then,
3,
how many can you fit in
4,
your...
8.
Okay, good.
Wait,
I
made me
also
lose
like
count. 5.
I like the order at which you're doing it, too.
6,
And then you pair
7,
them.
8, 9, 10. What do you mean I like the order? This is what I was taught.
Okay, well, good.
What do you mean good? What are you teaching?
Same thing, except the only difference is in the first orbit, I pair the electrons.
Look how easily I can turn this into a cat.
Okay, let's move on.
No, wait, I need those curses. There you go.
All right, so those are our Bohr-Rutherford diagrams. Next, I want you to look at this. Here is a periodic table of the first 20 elements, without all of the elements in between, which we call our transition metals, or multivalent ones. Okay, so we have the vertical columns are called what? Do you know?
Columns?
No.
Groups?
Groups, or there's another name.
Parallelograms?
What? No. Families.
What? That's stupid.
No. Families.
You
The
spelled families wrong.
No, I didn't. The horizontal rows.
It's families.
That's an M.
That's not.
Don't make fun of my writing. The horizontal rows are called what?
Columns?
No, columns are vertical. The
What?
horizontal rows.
But what?
Okay, these are columns, right? These are rows. But on a periodic table, the columns are called groups or families, and the rows are called, do you know?
No.
Periods. You haven't done that?
No? Wait, why is
So,
that?
This would be the first group. This is the second group. Third, fourth, fifth, sixth, seventh, and
Is that Roman
eighth.
numerals?
Yes, those are Roman numerals.
Why? Are you trying to be fancy and different?
No, I'm just doing the way it's always done. the first group or family actually has a specific name. Do you know what they're called?
Yep.
What?
Alkali.
Alkali metals. Okay. The second one?
Earth alkali.
Alkaline earth metals. Alkaline. This is
That's what I said.
alkali, and this is alkaline.
That's what I said.
Earth metals. Okay, and then we've got no special names for these. What about these ones? Do you know?
Staircase.
Staircase.
No, because... no, wait, I don't know anymore, okay?
Your staircase
The
is actually
metalloids.
over here.
Oh, whoops.
Okay, and so yeah, those would be your metalloids. Okay, these are your what? To the left of the staircase?
Yikes, I don't know.
Metals.
Okay, well,
And to the right
I thought they had a fancy
of your
name.
staircase?
Non-metals.
There we go. Non-metals. Okay, our first two groups have special names, and our last two groups have special names.
Noble gases.
Okay, so we know this one. Noble gases.
Is that how you spell noble?
Yep. Or it is L-E.
Get Grammarly.
Oh,
Wait.
that might be Nobel.
Yeah. Something you wish
There
you
we go.
had. Nobel Prize. Nobel Prize.
What is with you today? I'm gonna stop teaching you in a minute.
Whoa.
Okay. This one
I don't know,
starts with an
actually.
H.
Halo?
Keep going.
Halograms?
No, halogens.
I
Oh.
was like so close.
Really? Halo? It's not a video game. Okay.
Wait, Halo's a video game?
Isn't it?
I don't know.
Oh, whatever. Okay. Now, I'm showing you this specific periodic table for a reason. I want you to look at the Bohr-Rutherford diagrams because we've got some patterns going on here. Notice as we move, let's start with lithium. This last orbit is called our
I know this. I learned this, fool.
Okay, what's the last orbit called?
Starts with a V.
Yeah,
Kind of forgot what it says.
I was just about to say it.
No, I genuinely learned this. I forgot. Hold on, what's the name? It starts with a V. Valence shells.
Okay, so our valence shell. Okay, how many electrons in the valence shell?
1.
1. How about in beryllium?
2.
Good. How about in boron?
3.
Carbon?
4.
Nitrogen?
5.
You seeing a pattern?
Yes. 6. And it goes up to 8, right?
Yeah. Okay,
And
and that's true for any of them. If I were to jump down to phosphorus, how many would you think there are without counting?
Where's phosphorus?
Here.
5.
5, the exact same.
Yay.
Calcium, how many?
2.
2. Right, so this is a nice pattern.
Yippee.
Now another cool pattern is, let's look at our periods. In our first period, how many shells are there?
1.
So 1 shell. Or 1 orbit. And in our second period?
2.
2. And in our third?
3.
3. And in our fourth?
4.
4. So you could figure out the electron placement for Bohr-Rutherford diagrams even without knowing how many total electrons there are. You just know where they are on the periodic table. For example, chlorine should have 3 orbits, and the last orbit will have 7 electrons.
Okay.
Simple?
Yeah.
Okay. Now this can also help us figure out charges. So we're going to come back to this. But for now,
charges. I learned that.
we're going to do charges.
I can do that. And I can do that. I actually learned this like yesterday.
Okay. Let's start with magnesium. So magnesium on our periodic table. Okay.
Where's magnesium?
It's over here.
That says Ma.
Yeah, why does it say Ma? That's a mistake there. That should be Mg. because that's where magnesium is. Okay, 24 and 12. So we've got 24 and 12. So how many?
Wait, what's 24 and 12?
The bigger
Protons,
number.
Neutrons?
Bigger number is what?
Neutrons?
No, it's your mass number.
Oh.
You don't write the number of neutrons on like your periodic table. You have to figure them out. And this is your
Atomic number?
Atomic number. So for an uncharged atom, how many protons?
12.
12. How many electrons?
12.
Uncharged. 12. We won't worry about neutrons. They're neutral. Now, the ion that's going to be formed. This is interesting.
Fella.
Okay.
I got this. So, we looking at that charged atom.
Yep.
So, in protons, there will be 12. In electrons, there will be 10.
Okay. How do you know the number for protons doesn't change?
Because, it doesn't really matter for charged atoms.
Well, it's not going to change because those are in the nucleus. It's very, very hard to start stripping or adding protons to the nucleus. But electrons are in orbit. So we can strip them away or add them a lot easier. Right? And if we were to add a proton, it wouldn't be magnesium anymore. Right?
Yep.
Okay. How did you know there were 10 electrons?
Because, 2.
Plus 2 means what?
Plus 2 means you minus 2 from the electrons.
True, right? Because it means you have 2 more positive charges than negative charges.
Mm-hmm.
Okay. Do you know why magnesium becomes plus 2 and not plus 1?
Because it's easier to remove 2 than, add a bunch more.
Okay. You're comparing, say, magnesium versus chlorine. Okay. Let me just go to the side here. So magnesium, if we look at our periodic table, is here. Okay. It's in the 3rd period. So it's got 3 orbits. And in the last orbit, there's 2 electrons. Right now, I really only want to care about the last orbit. Have you done Lewis structures?
Huh?
Okay. So I'm just going to write Mg. And
but that's supposed to be for beryllium.
And we'll get back to it. I'm going to just put the valence electrons.
Okay.
Okay. Now,
yeah, it's easier to get rid of 2 than add 6.
But why would you want to get rid of 2 or add 6? What is it trying to become?
Stable.
Stable, exactly. And it's stable when?
The valence is filled up?
Yes. Okay. So we're going to get rid of these now. 2. Okay. So let's try beryllium. Okay, so beryllium, go back to the periodic table. Beryllium is here. Okay, it has 2, right? Because if we're looking at a group, 2 valence electrons. So that's why.
Eraser.
I'm trying to go back to the pen here. So that's why it gets a plus 2 charge. Nitrogen has a negative 3 charge because nitrogen has, if you go back to the periodic table, 5 valence electrons. So what's it going to do?
Add 3.
Add 3 because that's easier than subtracting 5, right?
Mm-hmm.
Okay. So we have a pattern. Let's look at our groups again. Change color. So the first group all has 1 valence electron. So what will they all do?
Get rid of minus.
They will get rid of 1 electron. So what will their charge be?
Plus
1.
All the way up until 4?
Nope. This is true for hydrogen, lithium, sodium, and potassium. They all have 1 valence electron. Right?
Oh, and then plus 2.
Plus 2.
And then plus 3.
Plus 3.
And plus 4.
Is it easier to lose 4 or gain 4?
What do you mean? Oh, I was thinking of 10. I don't know.
Let's just write plus or minus 4.
That's what you do?
Well, we don't really care about these ones in grade 9. But then nitrogen. Nitrogen has...
-5. No, whoa. -3.
Yes. And that will also be the same.
I see the pattern.
For phosphorus, yeah.
I see it.
So -3. And what's next?
-2.
-2. And then?
-1.
-1. And?
That's like already stable.
That's
why it's noble gases?
Yes.
I see.
Right? So they don't have a charge. They're not going to gain or lose anything. So with this pattern, you can immediately look at any element and know what ion it would form. An ion means charged particle. So aluminum, what's its ion going to be?
+3
Yep.
charge.
+3. Sulfur.
-2 charge.
Yes. Sodium.
+1.
Yes. Those metals will always form positive charges, and non-metals will always form negative charges.
Oh, I see.
Right? Fluorine.
-1.
Chlorine.
-1.
Sulfur.
-2.
Right? Magnesium.
+2.
Yes. Calcium.
+2.
Potassium.
Are we gonna do this for every single one?
Well, you're getting the hang of it though, aren't you?
I already have the hang of it.
Okay. Let's finish.
Let me do this.
Last test. It's all up to you. Fluorine, you know, is a halogen. Remember, it's the second last group next to noble gases. So it has a -1 charge. So, yep. And how many electrons? There we go.
And
Sulfur.
16. Ugh. Hold on, I'm thinking. Shucks! Wait, why is
Our
it?
next episode's going to be subtraction.
Me too. Let me see.
It's going to give you a negative number.
Whoops. Okay, wait.
We're going to be doing subtraction for our next episode, so make sure you subscribe.
Wait, I forgot how to do this! I did this in grade 1!
Oh my goodness.
Let me just grab a calculator.
No, don't you dare grab a calculator. Focus.
Wait, hold on. I completely forgot to do this. Okay, let me just get rid of, 30, 16. That's...
Wait. What?
Trust! Hold on, trust! So 30, 16 is 14? And then +2, 16.
Alright.
That doesn't make sense! Wait, no, it does!
I don't know what the heck you were thinking about, but you got the right answer.
Whoopsie daisies. Okay, hold on. 18. There you go.
Okay. Well.
I'm smart, I swear to God.
Now, I'm going to be giving her a bunch of arithmetic problems. Thank you for watching, everyone.
What's arithmetic?